Okay, Justine, we stopped here in the last class. Just one more thing was left here. We discussed electric field of a conducting plate. Then we discussed the electric field of a non-conducting plate. If you have combination of plates, that was just left. So let me discuss that quickly and I'll start with the next chapter today. So combination of plates. So in combination of plates, you can get two plates. Like if I say this is one plate, this is another plate. So here we have two plates. Now these plates are oppositely charged. Let's say here the charge is Q1, here the charge is Q2. These are the charges on the plate. Okay. Now when you have to calculate when these plates are connected together, these are just the like the parallel plates, you can say, like a capacitor, what we studied. But in capacitor, there is a condition. They have to be positively charged, one has to be negatively charged, and then there has to be a dielectric material present in between. Okay. Now here what do? We need to calculate the electric field. So remember, opposite inner faces, like if some charge, let's say, here what will happen when we will distribute the charge? Total amount of charge Q1 is given on this plate. Q2 is the total charge which is given on this plate. Okay. Now what we are doing, we are combining these two plates. So on this face, some other charge will be present. On this side of the plate, some other charge will be present. Similarly, means total charge is given as Q1. But on both the sides of plates, you will get charges differently. That's what is how your NEET syllabus is different from your CBSE syllabus. Here in CBSE, we used to just take sigma, one single plate and sigma we used to draw, and we used to write sigma by 2 epsilon naught. This part is not valid now. You have the both the sides of the plates are present. So what do? We will assume some X amount of charge on this side of the plate, let's say. Now by the process of induction, charging by induction we have studied. So by this process of induction, the charge will be exactly the same on the opposite side of it. See, you can relate this with the capacitor plates because you've already studied capacitance. You can relate it with the capacitor plates. If this is X, this will also be X, but this will be minus X. This is what we've studied in capacitance. Two plates are there, one positively charged, one negatively charged. So here, if this is some X amount, this will be minus X. So if this is X, on this side of the plate, see, total is Q1. So whatever is this, let's say this is some Q1 dash, let's say. So what will this Q1 dash be? See, this Q1 dash plus X will give me what? Q1 plus X means both of these charges will give me this mean charge Q1. Are you getting this? Just the mean charge is Q1. And we have divided and distributed it on both the sides of the plate. Till this, is this clear? Let's say this is some Q2 dash, this is some Q1 dash. Look, let me mark it properly. This is Q1 dash, this is Q1 dash and X make up your Q1. Minus X and this Q2 dash make up your Q2. Is this part clear, Jasleen?
Yes, ma'am.
So Q1 dash plus X will give me what? Q1. It will give me Q1. So what is this Q1 dash ultimately? Q1 minus X. So that is what you can write here. Instead of this Q1 dash, you can directly write here Q1 minus X. Why to have more variables? Q1 dash, X, Q2 dash. Why to have these variables? Straight away in the exam, don't write all these Q1 dash and all. Like write, this is for your explanation because you're doing it for the first time. Take it as X. Take this as, if this is given as Q1. Directly write Q1 minus X. This is some Q2 dash. So same story with Q2 dash. Don't write Q2 dash here. When you're solving, directly write it as Q2. Now, there's a catch here, Jasmine. See, when you have, let's say we were having some Q2 dash here, I'll write here Q1 dash, so you remember. Now look, what is this Q2 dash and minus x? Q2 dash plus minus of x will give us Q2, right? So we can say Q2 dash minus x will give Q2. So what is this Q2 dash equal to? Q2 plus x, because this sign was negative. So when you actually subtracted it, it became positive. So on this side, you will not write Q2 minus x. You will write Q2 plus x. Tell me, is the distribution of charge clear to you, Justine?
Yes, ma'am.
Okay, good. Now see, what you have to do here in the questions will be there. Electric field will be given to you. Just straight away use electric field will be, you use the formula of capacitance a little bit. One formula I'm telling you, directly you will get your answer. Whatever will be this value of x, that we will check. Whatever is this value of x, I'll tell you. Just remember what you have to do. Electric field, when you are asked, the formula of electric field is this x divided by a into epsilon naught. That's it. This is what the electric field is. Now, how to calculate x? Remember, when these two are equal and opposite, obviously these two will also be equal. Then only the charge will be conserved. So how can you utilize it? Your Q1 minus x will be equal to Q2 plus x. From here, you will get your value of x, right? That you can put here, you will directly get the electric field. So this is the toughest question that is possible out of the Gauss theorem's application. Maximum this can come, but this is not very difficult. If you look it properly, see what happened here. I'll just repeat it quickly. We have two plates. We are considering this side of plate, this side of plate, this side and this side, because it's a thick plate that is given to you. In your CBSE syllabus, we were just taking it as a single straight line. One side of the plate was only considered and both sides were taken equally. Now look, Jesslyn, what we are doing, total charges Q1, total charges Q2. Some X amount of charges here, we are assuming. So what will be left here? Q1 minus X, because total charge is Q1. Now this X will induce a negative but same charge on the opposite side by the method of induction. That's what we studied. The negative charges get attracted on one side. I gave you an example of glass rod, how it is attracting. This is how the methods of charging are applied in your throughout your syllabus. So minus X is here. Now when minus X is here, Q2 minus minus X. Here you will get Q2 minus minus of X. That is Q2 plus X. Now, since these are equal, these will obviously be equal because of conservation of charges. So this side you will equate it with this side. From here you will get the value of x. Once you have the value of x, you can put it in the formula x by a epsilon naught. This is directly your answer. Now for area, it will give you either area, it can give you sigma in terms of sigma, whatever it can give you, that you'll be able to calculate. Tell me, Jesli, is this clear?
Yes, ma'am.
Okay, please write down this one, then I'll start with potential chapter.
Done, ma'am.
Okay. See, now let's start with electric potential and capacitance. First, let us discuss some things about potential. Now, in potential, very tough questions have not come. Whatever we have studied in the board exams, those kinds of question only have come from your energy. Lots of questions are there from your energy. Then electric field as a gradient of potential. There are lots of questions from there. I didn't practice the superposition principle and all from electric field. So we'll do it in combination with electric potential. Many things are same. So a few things. You tell me, Jesslyn, what do you remember about potential? See, we discussed that potential is basically work done in carrying a unit positive test charge. Okay, that was the definition also. This is the formula. Okay. Now, see, here when you have the formula due to a point charge, can you tell me potential due to a point charge? Potential due to a point charge. Yes, Jesslyn, at least tell this. Potential due to a point charge. Yeah, V is equal to K into Q by R. Very good. Yes. This is K into Q divided by R. Now see, if you have a charge, here are two cases that are possible. If you have a charge, let's say that is plus Q, and at a separation of R, you are calculating this. So this potential will be K Q by R, but if this same thing is a negative charge, like this you have minus Q present, and at this point, let's say this point is sum A, here the point is sum A, R you are calculating, potential will be minus kq by r. Reason is that potential is a scalar quantity and SI unit is basically 1 joule per 1 coulomb, which is equal to 1 volt. This is the basics of the potential that you know. Now let's discuss one question. See, a charged particle. Now, from potential, usually you have the questions along with electric field only. So a charged particle of 1 microcoulomb is placed at 3 comma minus 2 comma 5. So these are the coordinates. Okay, coordinates of what? Position x, y, and z. So you have to convert it into I cap, j cap, k cap for solving. You have to find out electric field intensity and electric potential. I'll just write it. Find electric field intensity and electric potential due to a charge. Potential due to a charge placed at 5 comma minus 3 comma 7. Okay, this is the question. Now see, first, as soon as you see the coordinate system, you have to relate it with your universal unit vectors. In terms of I cap, j cap, k cap, you have to write them. What is given to you? The position is given 3 comma minus 2 comma 5. And where is the charge? This is where the charge particle is placed. But where do you have to calculate? Due to a charge at the position 5, -3, 7. So 3 is there, 5 is there. Basically 2 points you have. Okay. A charge particle of 1 microcoulomb. Let's say this is the charge, which is Q, whose value is 1 microcoulomb. This is placed at 3, -2, 5. All right. Then it is saying calculate all these electric potential, electric field intensity due to a charge placed at 5, -3, 7. So let's say there is some charge which is placed. Now this charge is placed at, what's the distance? 5, -3, 7. This is where you have all the atoms. So you are going to first make it into the Cartesian form. Let's say this is some point A, this is some point B. So our A will be equal to, this is 3i cap minus 2j cap minus plus 5k cap. And this our B is equal to 5i cap minus 3j cap plus 7k cap. So see, when we have to calculate the position, final position, how do you calculate? You subtract both of these, subtract R, you are going to calculate final minus initial, RBA, that is RB vector minus RA. So RB, this is 5i cap here you have 3i cap. So that will become 5 minus 3i cap plus, this is minus 3, this is minus of minus 2. This much j cap, right? -3 minus -2, subtracting. Plus here you have 7 minus 5 k cap. So what do we get here? This is 2i cap. This is -3 plus 2 minus j cap plus 2 k cap. This is the position that we have. Now for electric field, this is the R vector, the position. Okay. So see here, when you have to calculate the electric field, you can use the vector form also. Because when you're using the vector form in electric field, you will write K into Q into R vector divided by R magnitude of R whole Q. So for that we require the magnitude of this in vector form. See, magnitude of R vector will be under root of 2 square plus 2 square plus 1 square. See, this is under root of 2 into 2 is 4 plus 2 into 2 is 4 plus 1. That is root 9, which is equal to 3. So here, K will be 9 into 10 to the power 9. Charge. What is the value of charge that we should put in the formula directly? See? From the question, tell me. Yeah.
1 into 10 to the power minus 6.
Yes, very good. 1 into 10 to the power minus 6. So I'm writing 10 to the power minus 6. Now R vector, we can write this as it is. 2i cap minus j cap plus 2k cap. Like this. This is the vector divided by the square, that is 3 into 3 is 9. This gets cancelled. Here you will get 10 to the power 3. So 2i cap minus j cap plus 2k cap into 10 to the power 3 Newton per coulomb for electric field. Now for potential, let's calculate it directly. Also, you can calculate it is kq by r. So this is 9 into 10 to the power 9. Because this cannot be written in vector form. This will be always in scalar form. This could be written in vector form. So we use the vector. Here we just require the whatever is given. Like K, we know charge is 10 to the power minus 6. And position, magnitude of position is 3. So that's it. Because this is the scalar quantity. So you don't need to take that entire vector thing. Okay, here that is not required. But in electric field, it was a vector. So you can use the formula of electric vector. Now, Jesslyn, this depends on your options. Which kind of options are given? If it's given directly without these, then you have to use that. So this depends on options, what kind of options are provided. So this is 3 into 10 to the power 3. Is this question clear?
Yes, ma'am.
Okay. Please write it down from here.
Done, ma'am.
Yeah, Jaslyn, are you able to see the screen now?
Yes, ma'am.
Just tell me till where have you written so I can just show you the screen.
And I started writing the answer.
This question you've just started writing.
Yes, ma'am.
Okay. Just write it in the chat column. So I'll scroll it accordingly.
Done, ma'am. Done, ma'am.
See, Justine, when we are talking about the superposition principle, so only the basic questions are there that we have discussed already. So I'll just discuss it with you. Let's say we have a square and diagonals of the square are mentioned. And let's say here we have four charges Q, Q here, Q this side, and Q on this side. So when you are calculating the net electric field, see, electric field due to this positive charge will be pushed here. Electric field due to this positive charge will be on this side. Due to this positive, it will be away. For this positive, it will be away. So it's a symmetrical system. It's a symmetrical figure. So directly you can say at the center, the net electric field will be zero. What we have already studied. But when we're talking about the potential, potential won't be this, right? See, potential due to one single, let's say this side is A, this will become, this whole is A root 2, this will be A by root. So potential due to one of the face will be K Q by A by root 2. So total potential will be, see, this will be plus this, plus this, plus this 4 times. Your net potential will directly, you can say, see, when you see the figure is symmetrical, no need to write it separately. Directly you can say 4 times root 2 will go up, root 2 k cube by k. This will be the potential. Similarly, if you get another symmetrical figure, let's say a triangle. Let's say here you have a triangle. Now, Q charges are there, and again I'm taking the side as some A. So obviously this is the equilateral triangle. So at the center, when you're calculating the electric field, see how will it be calculated? Due to this positive charge, electric field will be here. Due to this positive charge, electric field will be here. Due to this positive, electric field will be here. Then you will calculate their resultant, which will be here. And ultimately, this resultant, they will cancel each other. So you will get again the net electric field to be zero at the center. Now, when you are calculating the electric field due to the potential due to this is the centroid of the triangle. So this side will be this whole length. This is the centroid of the triangle. This is A by root 3. So electric potential will be, see, you will add it how many times? How many potentials are there? Jesslyn, tell me. Like you will get one potential only, two potentials will be there, three potentials will be there. What do you think, Jesslyn? One potential will be due to this charge at the center. Yes, three. Very good. Three. So it will be directly, you can say for your NEET exam, 3 times. It's a symmetrical figure. For one, it is K Q by A by root 3. So this is the answer. That's it. This is how you have to deal with the symmetrical figures. So this is one square which usually comes, and this is another one. So for electric field, why it is net zero, we have already seen potential. Now we can see. So just add it. Whatever is the number, just multiply it with that. No need to take everything and add them. Please write this.
Ma'am, can you scroll? Done, ma'am.
Okay, next, Jesleen, just one more thing before you leave. See, when you have two charges and we use the equilibrium concept. So in equilibrium concept, let's take one example. One charge is there plus 4q. And here we have one more charge. Let's say it's just plus q. So on one side you're taking plus q, on the other, or let's take this as negative. Since we are calculating the potential, let's take this as negative. So this is it. Okay, and they are separated by a distance of a. See, when in the center you are calculating the net electric field will get added. This is the difference. Why? Electric field due to this positive charge. Where will it go? Towards A point or towards B point due to A? Yeah, just towards A or B due to A. Like towards this or away from this. Yes, Jesleen?
Ma'am, can you repeat? Your voice was lagging.
Yeah, I was saying this is plus 4q. Due to this charge, where will be the direction of electric field? Towards A or towards B?
Towards A
Positive charge. For positive
or
charge, it is
towards B?
always away.
Towards
This
B,
will
yeah.
be electric field due to it. And due to this negative charge, towards A or B?
It'll move towards B A.
Negative charge towards the charge. You're forgetting positive charge, you move away from the charge. So this was away. For a